Hi, everybody. We are Group 4, and today we're going to be discussing Section 2.4, Division of Whole Numbers 101. Let me go ahead and share my screen, and we'll get started. Have you ever wondered why division by 0 is undefined? Do you get tripped up by equations like 4 times 4 times 4? Hello, my name's Alyssa, and today I'm going to help you solve these mathematical issues. I'll be covering division by 0 is undefined and exponents and the power operation. So today I'll be discussing the difference between division by 0 and division into 0 to show you why 0 is undefined. So over here we have 6 divided by 0 equals question mark. Then we have 0 divided by 6 equals question mark. So we'll start with the division by 0, which is going to be our undefined one. Now down here I got a definition just off the internet because it kind of helped me understand things a little bit better in layman's terms for me. It says if you divide 6 by 0, then you're asking the question, what number times 0 gives 6? The answer to that one, of course, is no number, for we know that 0 times any real number 0 is not 6. So we say that division by 0 is undefined, for it's not consistent with division by other numbers. So to kind of contradict 6 divided by 0, we have 0 divided by 6. Now, division into 0 is defined. Our book tells us that. So if you type 0 divided by 6 in your calculator, you will get 0. You're also asking yourself what number times 6 equals 0, and that is 0. If you type 6 divided by 0 in your calculator, it's going to say error. It's going to say not divisible by 0 or something like that. So to go further into that, one of our Khan Academy videos that we watched this week told us that comedian Steve Wright kind of said black holes are where God divided by 0 because it's saying you can't find the answer. It's just not there. So next we're going to talk about exponents and the power operation. Rene Descartes introduced the notation known to us as an exponential expression. So instead of writing out 3 times 3 times 3 times 3 times 3 times 3, we would simply write 3 to the 5th power, or right there it'll say 3 to the 5th. So the components of an exponential expression look like this. These are your components. You have 4 times 4 times 4, and so 4 will be your base, which is your larger number, and 3 will be your exponent because 4 is written there 3 times. So let's explore some problems containing exponents. We'll have a multiplication one and a division one. So let's start with the multiplication. We have x squared times x to the 5th power. So for the multiplication exponents, you're just going to add your exponents. So that'd be 2 plus 5, and you come up with x to the 7th power. So for division, we have 6x to the 4th power divided by 3x squared. You divide the 6 by the 3 because you have like bases, so that's allowed. So you'll get 2. And then you have x to the 4th power minus the 2 right there, because for division you subtract, you don't add. So your final answer is going to be 2x squared. Now the neat thing about exponents is we encounter them in everyday life without really even noticing, because exponents can help us measure surface area. So right here I have an example of 1 foot times 1 foot equals 1 foot squared. So that just shows you can, whenever you're measuring area in a room, you're always going to have that exponent there. And also algorithms contain exponents, and algorithms are what make up our computer programs. They help make up video games if you play them. So I just have a little example of this is kind of like an algorithm right here. You have numbers, you have letters, and most importantly, you have exponents. So I hope you have a better understanding of why division by 0 is undefined and how exponents and the power operation can make your life easier. Now Chelsea is going to talk about the partition model of division and the missing factor model of division.
Thank you, Alyssa, for going over division by 0 is undefined and exponents and power operations with us. My name is Chelsea, and I will be going over 2 different models of division with you. Let me pull up my slideshow here. All right, and the 2 different models that we're going to be going over are the partition models and the missing factor model. First, we're going to look at the partition model. What is partition division? Well, it is a way of understanding division in which you will divide an amount into a given number of groups. And I have 2 example problems here for you. The first one is Karen had 12 apples. Her apples were in 4 bags, and each bag had the same number of apples. How many apples were in each bag? So a good way to solve this is using division. You're going to take your 12 apples, your total number of apples, and you're going to divide it by the number of bags that you have. And that's how you will come up with your answer, or how many apples that you'll be placing in each bag. And then my second example here is you have 16 cookies to share with 3 friends. How many cookies will you get if you share them equally? So it tells you here to divide the 16 cookies into 4 separate piles, 1 cookie at a time. When you're finished, there are going to be 4 cookies in each pile, so your answer will be 4. So it's 16 divided by 3 equals 4. Next, we'll be looking at the missing factor model. And it's kind of how it sounds, the missing factor. So for whole numbers A and B, where B cannot equal 0, then A divided by B equals C if and only if A equals B times C for some unique whole number C. And in these type of problems, it will not work if you have division with remainders. So the first example I have here is going to be 20 divided by 4 equals 5. And it just basically shows you that that is the exact same thing as 4 times 5 equals 20. And it gives you multiple examples here. We're going to look at the second example I have here. It kind of gives you a better understanding of the missing factor part of it. So your factor 5 times your factor n, which is the missing number, will equal your 20. And then it shows you down at the bottom that 20 divided by 5 equals n. So it's the same thing there. Alrighty, I hope that this presentation has helped you have a better understanding of the partition model and the missing factor models of division. Next, Akeisha is going to be going over division of whole numbers with you and the repeated subtraction method.
Hello everyone, thank you Chelsea. Thank you for talking about the other 2 methods of division. We're going to be talking about the third as well as what is division itself. I am Miss Akeisha, and let's get our PowerPoint started. So we're in chapter 2, sets and whole numbers. Division of whole numbers is the whole topic of what we're discussing. Here's some vocabulary and terms that you're going to hear throughout this part of the lesson. Division. It's written A divided by B or A divided by B like you see here. And so you're going to let A and B be whole numbers, but B cannot equal 0. Then, if A divided by B equals C, if and only if A equals B times C for a unique whole number of C. So dividend is usually the bigger number. So in this case, it's usually A, with the divisor usually being B, the smaller number. And quotients is always going to be the answer. Division by grouping or measurement division is some terms that you're going to hear interchangeably. Here's a handy dandy little chart of division. Got your dividends, divisor, quotients, and remainders. So division of whole numbers. Caution, this may be more difficult than multiplication. Because after all given A and B, that are whole numbers. So A and B, if you multiply them, they're always going to be a whole number. But if you divide them, you may not get a whole number. You may get some remainders. So we've heard about partition and missing factor, and I'm going to talk about repeated subtraction. So you're also going to hear it called division by grouping or measurement division. Here you can see 33 divided by 5. So you're going to subtract multiple times. 33 minus 5 is 28. 23, 18, 13, 8, and 3. We can't subtract 5 from 3 because then you'll get a negative number, and you don't want that. So you're going to leave it like that, and you're going to have a remainder of 3. I lost my little mouse. So then you'll see 1, 2, 3, 4, 5, 6 5s went into 33. So 33 divided by 5 is 6 with a remainder of 3. See how that works? So here we have a whole bunch of cute little bunnies. Look how cute they are. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We're going to divide them by 3. This is grouping. Aha. So 1 group of 3, 2 groups of 3, 3 groups of 3, and 1 little remainder. So 10 divided by 3 is 3 with 1 remainder. See how neat that is? So we're going to try it out for ourselves. 37 divided by 6. Now start with our 37 minus 6. I'm going to get 31. Divided by 6 is 25. Sorry, my handwriting always looks atrocious with this pen. Divided by minus 6, sorry. And you get 19. But minus 6, 13. And I'm running out of room, so we're going to go right back to the top. Minus 6 is 7. One more 6 is going to give us 1. Now you can't subtract 6 from the 1. That's going to give us a negative. We don't want that. So let's count how many 6s we got. 1, 2, 3, 4, 5, and 6 6s. So 37 divided by 6 is 6 with a remainder of 1. See how we got that? All right, let's do one on our own. We got 45 divided by 5. Pause it if you need to, but here comes the answer. See? You work your way down the page. You got 1, 2, 3, 4, 5, 6, 7, 8, and 9. 0 remainder. See that? So we have 45 divided by 5. Answer is 9. Woo! Now we're going to go to Miss Heather, and we're going to talk about divisions with remainders and why quotients with remainders work. Thank you. I hope that you have a better understanding of division and the repeated subtraction model of division.